Some A-level students were given the following question, and they're trying to solve that in the interval of minus 90 to 90. So we're given student A's and student B's solutions. We're trying to figure out what is the error made by student A. So for these kinds of questions, if you find them difficult, what I'd recommend doing is ignoring what the students have done and then just trying to solve the question yourself. Once you've solved the question yourself, then you can have a look at their working to see what went wrong. So part A is quite straightforward. The student basically used the identity incorrectly or rearranged incorrectly. If we were to divide both sides by sine theta, we'd end up with cos theta over sine theta, which is 2, and cos theta over sine theta is not equal to tan theta. So there's the mistake made by student A. For part B, student B gives theta is equal to minus 26.6 as one of the answers to the equation. We're trying to explain why this answer is incorrect. So if we put in minus 26.6 into the equation, so cos of minus 26.6 is 0.894. And then if we were to do the right-hand side of the equation, so 2 sine theta, 2 sine minus 26.6, this gives us minus 0.896. So they're off a little bit at the end, but that's just because we have rounded the angles. The angles are not exact. But the main difference is that one side of the equation is the negative of the other. So these are the same number, but one is negative. So then to finish off this question, we could say that cos of minus 26.6 is not equal to 2 sine of minus 26.6. So why has this arisen? That's question 2, part 2. Why did this incorrect answer arise? So the reason it has arisen is because we have squared both sides of the equation. So I'll show you an example of this as to why this error can arise. If we were to have, let's say, x minus 2 is equal to 3, well, this has a simple solution. You can just bring the minus 2 to the right-hand side and you end up with 5. So simple equation. When you square both sides, x minus 2 squared is equal to 9. If we were to solve this equation, the easiest way to do that would be to square root both sides first. So we'd end up with x minus 2 is equal to, and when we square root the 9, we'd have to introduce a plus or minus, so that becomes plus or minus 3. We could have put the plus or minus on the left-hand side as well, but you just have to have it somewhere. And then when you rearrange this, you end up with x is 2 plus or minus 3, which gives us two solutions, 5 and minus 1. So the 5 is correct. When I say correct, I mean with reference to the original equation here. The 5 is what we got earlier, so that bit's fine. But then we end up with an extra solution. We end up with minus 1. And minus 1 is not a solution to this original equation here. So what we see is that by squaring both sides of the equation, we have ended up with an incorrect solution. Okay, so if we look at the actual steps that student A has done, nothing's incorrect. The student has squared both sides correctly. They squared each individual term. They've changed the cos squared into 1 minus sine squared using the identity. They've rearranged correctly. They've square rooted both sides correctly. And then they found out what theta is correctly. But then the mistake is that they should have then put both of those numbers back into the original equation. So whenever you square both sides of an equation, I'd recommend doing this. Put the final solutions back into the original equation to then see if you have got any incorrect solutions. And they then would have found that the minus 26.6 was an incorrect solution. Okay, so let's just summarize that to finish this question off.